Assalamualaikum and good day. My name is Nurul Fakhira Bt Abdul Hadi 2019902793 class RAS 2456A will be presenting about my final year project, Antioxidant Activity of Lentinula edodes and its potential as a lip balm. This video will be divided into 4 parts, which is Introduction, Method, Results and Conclusion. Shiitake mushroom, Lentinula edodes, Pegler, is a staple food in Japan. Since the mid-1990s, polysaccharide, the primary ingredient and bioactive chemical in Lentinula edodes, have been studied for their nutritional and pharmacological effects. They are soluble and insoluble dietary fibers in Lentinula edodes. The beta-glucan and proteins are present in the water-soluble. Lentinula edodes may be used as a lip moisturizer to boost antioxidant defense and protect against UV rays. Studying the problem statement. In response to growing public concern about cosmetic safety, new methods for making organic items are being explored. Due to the issue, more natural resources are being used to replace synthetic chemicals. The main objective of this study is to determine the antioxidant activity using DPPH method by using solid extraction of Lentinula edodes and its potential as lip balm. This objective is further divided into sub-objectives as shown. Lentinula edodes are cultivated on forest floor logs and inside on artificial soda substrates. Lentinula edodes is a lignocellulosic fungus with an enzyme system that enables it to utilize complicated carbon sources including cellulose, hemicellulose, and lignin. For sample preparation, Lentinula edodes were dried in an oven at 100 degrees Celsius. Subsequently, the dehydrated mushrooms were milled to powder, homogenized, and kept in the dried place at room temperature. And then, the 10.17 gram of dry and ground sample of Lentinula edodes were extracted using the solid apparatus as shown in the video. The solvents, which are 200 ml of ethanol, were used in the solid extractor, and the extraction was performed for 4 hours. Then, a vacuum rotary evaporator as shown in the video was used at 83 degrees Celsius at 90 rpm to evaporate the extracted solutions, resulting in a viscous mass. Before being kept at 0 to 4 degrees Celsius for subsequent analysis, the crude extract will weigh and dilute. The following equation were used to determine the extraction yield. Phytochemical screening was performed as a reference. The crude sample of Lentinula edodes was taken from the solid extraction. Alkaloid, carbohydrate, flavonoid, phytosterol, tannin, steroid, saponin, gum and mucilages were done. As for antioxidant tests, stock solution, negative control and positive control were conducted as shown in the table. For antioxidant tests of sample, extract stock solution were obtained and the absorbance were observed at 157 nanometer wavelength and conducted an IC50 value. The formulation of lip balm in this study followed method by Azmin et al. 2020 with some modification. The hot mix of beeswax and shea butter, VCO and Lentinula edodes powder were poured into a lip balm containers and stored at a room temperature to stabilize the composition of the lip balm. The result of extraction of Lentinula edodes were done by using solid extraction. Based on this study, 18.39% extraction yield was obtained. The results for FTIR were tabulated in the table. For FTIR spectrophotometer, Lentinula edodes contain polysaccharide and the compound that has been extracted is beta-glucan, inconsistent with the study done by Murphy et al. 2020. The chosen polysaccharide exhibit a distinct band between 1196 and 1067 due to presence of CO, which is ether, for glycosidic leakage and CH anomeric carbon respectively. On the analysis of phytochemical screening, the Lentinula edodes aqueous extract revealed the presence of secondary metabolites such as alkaloid, phytosterol, flavonoids, tannins, gums and mucilages in the mushrooms. However, saponins, carbohydrate and steroids were not detected in Lentinula edodes. Based on this study, all the results of phytochemical screening tests conducted agreed with previous literature study. In this study, the antioxidant activity of the Lentinula edodes extract as natural antioxidant was determined using DPPH method. Figure 4.2 shows the color changes in sample solution after added with DPPH solution. The color change to yellow shows that the DPPH radicals were being scavenged and indicates high antioxidants activity of the sample. Average percent inhibition of the ascorbic acid and lentinula edodes extract was shown in tables 4.4 and 4.5 respectively. Although lentinula edodes shows lower percentage inhibition compared to ascorbic acid, it still has potential to act as an antioxidant agent since the percentage of inhibition value is only slightly different. Due to the fact that percent inhibition is inversely related to absorbance, the greater the absorbance value, the lower the sample's percent inhibition. The linear regression line between concentration and scavenging activity of ascorbic acid and lentinula edodes extract was generated as shown in figure 4.3 and 4.4, while figure 4.5 shows the graph of DPPH scavenging activity by comparing between ascorbic acid and lentinula edodes extract. Correlation coefficient R were 0.69072 for ascorbic acid and 0.953593 for lentinula edodes extract. According to Akoglu 2018, a correlation coefficient of 0.64 indicates a moderate to strong connection with a very high degree of statistical significance. The greater the concentration, the more effective it is in scavenging free radicals. The correlation coefficient between concentration and scavenging activity is high. As for IC50 concentration result for lentinula edodes, it is found that IC50 value for sample is 27.9962 microgram per ml, while for ascorbic acid is 12.9158 microgram per ml. The smaller the value of IC50 cause, the higher antioxidant activity of a compound. The lip balm was tested under organoleptic test and the results as shown in the table at room temperature. For the prepared lip balm, it was light brown in color when placed at room temperature and had a cleansing aroma, while at refrigeration temperature, the color slightly changed to cream in color, and in incubator temperature, it turns into brown in color. For spreadability test, as shown in figure 4.7, the lip balm was regarded to have an excellent spreadability, which is good when no deformation occurs and no fragment left on the glass slides. Additionally, the pH of lip balm formulas is always within the range recommended for human skin, and the ideal pH range for the skin is near 7.2. The pH of the prepared lip balms in this study was 6.5 as shown in figure 4.8, and it can be considered as safe and within the optimal range for the typical human skin. The greasiness of each lip balm was determined after 24 hours at room temperature on filter paper. The diameter of the oil ring was determined in order to determine the greasiness of each lip balm. Commercial lip balms have an average diameter of ring 7.5 cm. According to figure 4.9, the diameter of the oil ring was 1.5 cm, which is less than 7.7 cm. The irritability test was used to assess the response caused by the skin after busting. Based on the findings of the test observation, the panelists conclude that none of the formulation caused skin irritation after 10 minutes of busting when repeated for 3 times. The findings of this irritation test indicate that the prepared lip balm is acceptable to be used as lip balm. As for the stability studies, stability investigation were conducted at room temperature, refrigeration temperature, and incubator temperature for 1 month. Table 4.7 summarized the findings. It was determined that the produced lip balm exhibit the following characteristic, which is good: uniformity, absence of fragmentation, flawless application without deformation at room temperature and refrigeration temperature and incubator temperature. Additionally, the spreadability analysis demonstrates that there is no noticeable difference between the conditions. It may be concluded that there is no apparent variation in the performance of these 3 lip balms at various temperatures. As a conclusion, lentinula edodes has a great potential to be used as a natural source of antioxidants agent. Lentinula edodes was successfully extracted by solvent extraction using ethanolic solvent with the percentage yield 18.39%. Based on FTIR result, the extract lentinula edodes shows the prominent functional groups comparable with functional group for beta-glucans. From phytochemical analysis of ethanolic extract revealed that lentinula edodes contain alkaloid, phosphosterol, gum and mucilages, flavonoid and tannins. When compared to ascorbic acid, lentinula edodes exhibits fairly high level of antioxidant capacity as compared to ascorbic acid that possess a very high level of antioxidant activity. Besides that, a natural lip balm using extracted lentinula edodes have been successfully prepared in this study. Each lip balm was evaluated for its physochemical features. Hence, the best formulations were found, which is the mixture of 0.2 gram of Lentinula edodes powder, 0.85 gram beeswax, 0.75 gram virgin coconut oil, and 2 gram of shea butter. Lentinula edodes extract as a natural antioxidants maintain their color, flavor, texture, and as well resulting in a homogeneous structure. That's all from me. Thank you for your time.